Alright, video for 7.2. As you notice, with IP version 4, we didn't have enough IP addresses, and we had to start doing some funny stuff. Classless, IP addressing, stuff like that. Well, they decided let's go crazy and go for IP version 6, which means we have way too many IP addresses. Well, not way too many, but a lot of IP addresses. And to bring the point home that we're running low, look at the dates that these are running out. So in this case, these places are literally doing some funny, funky stuff to make this work. So yeah, kind of rough, but it's the way it goes. Now, while we're transferring from 4 to 6, you need to have a transfer protocol, or transition protocols in play. So we have this dual stack is one of them. There's 3, and dual stack's 1. So we have IP version 4 and B version 6 working at the same time, and they just use whichever one works, which is kind of by default way yours are set up. Your home routers are set up, but that's going to change a little bit. So you have IP version 6 and IP version 6, and then you have a tunnel through IP version 4. That's called tunneling. This is if you have one network on IP version 6, a satellite location over here on IP version 6, but the rest of the network you're on is IP version 4, which is still pretty common. Then we have translation. IP version 4 translates to 2, and IP version 6 translates to an IP version 4 network and back and forth. Again, something you still see a lot of. Try this out. Figure out which is which. You can do it. Now here is IP version 6 represented. It is 128 bits. Not 32 like an IP version 4, 128 is 4 times. I don't know. IP version 4 is 1/4 of IP version 6. 4 times or 3 times? That's 4 times. 4 times bigger. In order to do this, we actually added more on. We have the decimal the binary we talked about, where the 1s and 0s, this part right here. What you're used to seeing is binary right here. Then we have hexadecimal, which means that each spot represents 16, and so on and so forth. So it goes up crazy high. Format examples. This is what it looks like. This is what it's going to look like. You're going to have these. You have letters with the numbers. It's annoying. Now, because they're so long, nobody wants to read that. So they came with a couple of cute ways to shorten it out. For example, you can omit all leading zeros. So the zeros on each. They're not called octets. What are they called again? Got ahead of myself. Hextets. There you go. I forgot. Don't work with as much. You still work a lot with RP version 4. 6 is, like I said, I told the class here, it's slowly being implemented. So these hextets, you get rid of the extra ones. Now you can shorten it down to this, and then compress it again. Oop, got ahead of myself one. You get rid of this. Here again, more examples. So you have much shorter. But that's still not short enough, so we compressed it. So if you have several zeros in a row, you have double columns. Double colons, but only in one spot. You can't do it twice, otherwise you won't know how many gaps are in it, on which spot. So you see you have the 0 over here. Are there any others? Yes, but only be used once. So it's either here or like this, one or the other. You can do it both. Otherwise you won't know, because this could be 1 over here, this could be 3, or is this 2 and 2, or what? Give this a try, so you can remember the stuff. You don't need an expert on it, you just need to know what exists. Unicast, multicast, unicast. Unicast is the same way. Multicast is to multiple things. You don't really have a broadcast anymore. Unicast was literally sent to the nearest device. I'm not really sure the purpose of this, but they say it's beyond the scope of this course. Don't really worry about it. Like I said, I'm not really sure what the purpose is, but I'm sure it's there if they made a point of putting it in there. Prefix length. It's half and half. You don't do subnetting. You can do subnetting with IP version 6. You don't have to because there's so many right now. Eventually we will, but right now we don't. So by default it's 64/64. This is it by default. You have a halfway. Is the network. This is the interface ID or host. They call it prefix and they call it interface ID now. Whatever. So they break down into different types. Global unicast, link local, loopback, unspecified, unique local, embedded, IP version 4. Each serve a different purpose. Global unicast is globally unique. Link local is only for your network, so you don't actually have to use the router. It just completely bypasses it if you use link local. Loopback is like the loopback for IP version 4. It just loopbacks to itself. Yay! Unspecified and unique local. Again, have learned the purposes. And this is for the working with IP version 4. Go ahead and read it down. Link local and unique local are slightly different. Read them. Me explaining it may or may not help you. I suggest you read it. If you have questions, email. And then link local doesn't even go to the router. It still uses IP addressing, which I think it might push more effort onto the switches than before. Break this out, give it a try, see if you can figure out which is which. Structure. Unique global. These are unique to the whole internet. So this whole having end-to-end connectivity, this is where that comes from. This is the important part this plays in here. So you can have your global free reflex. You have your subnet ID, which is already built in right now. But if you default back to actually having to do subnetting, you go back to 48 and then you work your way up on the subnetting. And then 64 is still the host. Pressed, preferred. Subnet ID is this last hex stat right over here. How do you put it in? Same way you do it with IP version 4, except for instead of IP address, you put IPv6 address and the 6 entry. In fact, this is all the commands on the Cisco. Okay, this is what it looks like with IP version 6 instead of 4. How do you get these out? Well, we do it with DHCP with version 4, but we can do the same thing with version 6 if we want to. Or we can do something called Slack, which means the server will do it for you. Or you can do Slack and DHCP, which is, I understand, the most common when actually implemented. Like I said, it's still being very, very slowly implemented, so I have personally never run across anything other than classes. So, yeah. I've done it a few times in class, but I've never in projects for classes, but I've never actually done it in the actual production environment. So, as I said, slowly being implemented. This is how it works. It actually asks the router to all nodes, give it a try. Like I said, stateless DHCP, which is this. Right here, Slack DHCP, that's stateless DHCP. Stateful DHCP is this. So you hear them say interchangeably. So, read it through. It's kind of funny the way that it does this. Yeah, look at all this extra stuff. You really, you can do it, giving it to this EUI64 process, or randomly generated, which means it can actually generate itself. Again, I know the differences between the two, but I don't understand the purpose of them. I'm sure I think it's probably for smaller networks, and this is probably for bigger defined networks, I'm guessing. I would think, based on what I've learned myself. But it can generate this stuff itself. And as you notice here, you're going to have more than one IP address. Link local and IP version 6. And link local are always this FE80. Always FE80. And link local address using this program, which shoves in the MAC address. The last 3 of the MAC address. How do you configure a link local? If you need to make it static, typically it's dynamic. IP address, the link local address, and then link local command. And you want to keep this in the FE80 range. I know that. How do you verify? Show IPv6 interface brief. Everything else, the same commands. I show IPv6 route, except for it's IPv6 instead of just IP. Yeah. So multicast. Again, it works the same way. It's FF02. So that tells it everybody. All nodes multicast. All routers multicast. So they break it out between just everything and then to every router with IP version 16 cast routing going. So again, they've added more functionalities to it, which makes it IP version 6 by itself more complicated, which makes it kind of a bit more of a harder cliff to climb to get started. But it does everything at once. So once you get it, you get it. With IP version 4, you kind of tack on a little more, tack on a little more, tack on a little more. When we do those worksheets later on, you'll see what I mean about tacking on a little more, little by little. This is almost like a history lesson on IP version 4. Again, read through these things. Alright, we'll stop here, and I will do 7.3 as its own separate video.